Okay guys, in this chapter we're going to start surface area and volume of pyramids and cones. And so first I want to start out with the simpler of the two, which is surface area. Okay, surface area, you should know is the area of all the faces, we say, all the faces of a three-dimensional object. If you add all of those up, that would be the surface area. So for example, if you're a box manufacturer, you need to know how much cardboard you need to make a box. Or if you're a drink manufacturer, you need to know how much, I don't know, aluminum or plastic is in a bottle. Even though these aren't cylinders or boxes, we're going to deal with pyramids, and that's basically what surface area is going to be. And so surface area, if you think about it, in pyramids, it's always going to be the same. In pyramids, the surface area, okay, so the surface area is going to equal, if we look at this surface area, it looks like how many rectangles are there? Okay, or sorry, how many triangles are there? Well, in this case, there's 4. If there was a pentagonal pyramid, there would be 5. If it was triangular pyramid, it would be 3. But basically, it doesn't matter. We have to find the area of all of these triangles and then add on the area of the base. So how can we figure out the area of all these triangles? Well, if we look here, okay, we're going to call this L, which means the slant height. Okay, so the slant height is different from the actual height, but we have the slant height. And if we look here, then let's say this is the base of one of the triangles. Okay, so this is the base of one of the triangles, so the base and the height of a triangle. Now if we do that 4 times, 1, 2, 3, 4, okay, then instead of one base, 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 and base, okay, if you add all of these bases up, that's going to be 4 bases, okay, or we could call it the perimeter. So surface area is going to be 1/2. Instead of base times height, we're going to do 4 triangles. So 4 triangles, the area or the base of 4 triangles added together is the perimeter, times the slant height, plus the area of the base. Okay, so this is called the lateral area. Okay, so when we talk about sometimes surface area, we talk about lateral area. Lateral area is the area of the faces, and then we add on the bases later. Okay, so this is sometimes called the lateral area. Now, this is a surface area of a pyramid. Okay. Now, so this is where the equation comes from. In the next, in subsequent videos, we're going to be doing some problems with them. But you can think of a pyramid and a cone as very closely related cousins. Okay, so you can think about the surface area of a cone. Okay, now instead of P, well, of course, a cone doesn't have a perimeter. Instead, it has a circumference. So we know that the circumference is 2 pi r. Okay, so that's going to be our perimeter. L is here, plus base. Well, the base of a pyramid or the base of a cone is always the same, and that's going to be pi r squared. Okay, so we sometimes write the surface area of a cone like this. 1/2 times 2 is just 1, so pi r L plus pi r squared. Okay, so these two are the 2 equations you're going to want to commit to memory. Although if you only have room in your memory for one, then I would commit this one to memory, because this works for pyramids and cones. If you just generalize, think what's the perimeter of a circle? Okay, it's 2 pi r. What's the area of the base of the circle? And so these are our 2 formulas. So I think that's fairly easy to see where that comes from. Now, what is not as easy to see, and this is going to require some good artwork on my part, what is not as easy to see is the volume of a pyramid, and I'll just give it to you, is 1/3 area of the base times height. Okay, so this is something that seems completely arbitrary, completely random, doesn't really make sense where it comes from, but I'm going to try to illustrate where it comes from and show you a little bit about that. All right, so I've got to be very careful drawing here. so far I think I'm okay. Okay. And so imagine I have a cube here. Okay, imagine I have a cube here. We have S, we have S, and we have S. Okay, standard cube. Let me draw these points in here. Okay, so I've got a cube here, and I want to pick a point in the very center of this cube, the very center of that cube. Okay, remember I told you guys in area, if you want to find if you want to find something out you don't know, you have to use something that you do know. So we know how to find the area of cubes, but we don't know yet where this comes from. So I'm going to use cubes to sort of assist us. Okay, so imagine that I draw in some lines from the vertices to this center point. Okay. So I've drawn 8 lines here. Okay. Now that looks a little bit messy of a drawing. But my question is, how many pyramids are in this cube? How many pyramids are in this cube? Okay. Take a look at that for a second. All right, you should have guessed more than one, hopefully, but there are in fact 6 pyramids. There are 6 pyramids, okay? There's top and bottom, so top and bottom. There's left and right, and there's front and back. Okay, so there's these two, there's these two, and there's these two. Okay, so top and bottom, left and right, front and back. All right. So hopefully you can see that a little bit. Now I want to find the volume of this cube. The volume of the cube equals, of course, that's very simple. Side cubed. Okay, we already know that. But I want to use this to find the volume of one of these pyramids. Okay, how am I going to do that? Well, we know that the volume of a pyramid, okay, so the volume of a pyramid, okay, I'm just guessing here, it's going to equal some sort of combination. Okay, let me draw this in here. Okay, I'm guessing it's going to be some combination of maybe length times width times height, right? The height of the pyramid. So let me draw in the height of the pyramid here. Okay, so I've got the height of the pyramid. I'm guessing it's going to be some combination of length or side times side, or length times width times the height of the pyramid. Okay, so we'll call this h. So I don't know what that something is. I don't know yet, and that's okay. But I'm guessing it's going to be side times, this is not, the height of the pyramid in terms of the cube, that height is not going to be s, but it's actually half of s, right? So half of s. Times half of s. Okay, so where am I going with this? Okay, and we know that there are 6 of them, right? We know that there are 6 of these cubes in there are 6 of these pyramids in this cube, right? So we can multiply this by 6 and this by 6. Okay, so there are 6 pyramids in this cube. Okay, we know that the volume of the cube equals s cubed, and I know that there's going to be something. I said that there's some number, I'm guessing, there's some number that's length times width times height. Of course you can see, let me just illustrate what that looks like for you. Okay, so length times width times height looks something like this. Okay, see this box I'm drawing here? All right, it's got to be really careful here. Okay. What I'm arguing is that, see this lower prism, right? This lower prism, some factor of length times width times height, because length times width times height, this is going to equal the volume. This equals the volume of the prism. Okay, Okay, so that equals the volume of the prism. So it's obviously not all of this bottom pyramid here. Obviously not all of that space is the volume of the prism. That's obvious. But I don't know what that factor is. And I'm going to do some algebra here, and you're going to hopefully see what happens here. So we know that these two must be equal, right? The volume of this whole cube must be equal to this, okay? They must be equal. And again, I don't know what this factor is, but let's go ahead and see what this looks like. S cubed equals 6 times 1/2 is 3, 3 times S times S times S times question mark. Okay, so in order for these things to equal each other, question mark must equal 1/3. Okay, now remember, let's go back. I said some factor, some portion of this orange-topped prism, some portion of this orange-topped prism equals the volume of this one pyramid, right? Well, it looks like 1/3 of that. Okay, so 1/3 of S times not S, but this is going to be H. Okay, this height from here to here is going to be H. So it looks like the volume is going to be 1/3 of this prism. It's going to be 1/3 of this prism. S times H, okay, that prism, 1/3 of that is going to be the pyramid. And I've shown why that is here, because it must be 1/3 for this equation to balance out. Okay, so this is not arbitrary. It's in fact, it comes from this idea. Okay, so I hope you could follow along with that. Maybe pause, rewind, rewatch it. But this is really a cool thing because it seems totally random. And I think in a lot of schools, your teacher just says, okay, here's the equation, and then go do some problems. But that's really like a seventh grade skill. You should be kind of understanding where this comes from. So this is the volume of a pyramid, and the volume of a cone is just the it's just it's a specific case of this generalization. So it's 1/3 pi r squared h. Okay, so hopefully this helped you understand where these formulas come from. In our next videos, we're going to be looking at again, pyramids and cones, parts of those, and then do some actual problems. Thanks for watching.